go. Let's go. Let's go. Let's go. Let's go. Let's go. Me post it quickly. Oh, got a notification. Two lanes swimming and diving. Two lanes swimming and diving. Holy shit, there is two lanes swimming and driving. Diving, my bad. Oh, Valentina posted. Oh, nice. Anyways, I don't care, don't care, don't care. I need to post it. I need to post it on Instagram because you get good amount of views. So please, come on, come on, come on, come on. Please, please, please. For Valentina Gomez Noriega. For Valentina Gomez Noriega. Viral. I know my hashtags are generic, but you know what? I don't give a shit. Honestly, at this point in time, I just can't care. I can't care less. Come on, man. Anyways, and it's posted. So let's just continue with where we stopped. We stopped at. Wait, what's this? No, we can't do. We shouldn't be doing this one though. We should be doing the other one, right? Yes, this book here. Let's go. Let's move to rigid body equations of motions because they have a lot of equations, and my iPad still didn't open. There, I think there is something wrong with the either the charger or the iPad, but I don't think there should be anything wrong with the iPad. At least as far as I know, there shouldn't be anything wrong with the. But me, I think there is something wrong with the cable inside because I see there's burning and stuff like that. Why is it burning? Because I tried using the. Oh, come on. I tried. Oh, shit. What? 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 There you go. So I tried using one of those for my iPhone 15 charger. You have the Type C charger. I used one of those and it works. I don't know. I'm not sure. Like, probably it's the cable, either or. I think just going to move it there. I don't know. This cable is somewhat useless now. That's why I need to buy one of those iPad that has the Type C cable in it because these get very sensitive. Just going to buy another one of those. It's fine. Put some fan here. Yeah, very cool. Anyway, so we'll just begin with rigid body dynamics. In this section, we'll consider a typical missile and derive the equations of motion. According to the Newton's law, in deriving the rigid body equations of motion, the following assumptions will be made. So, okay, rigid body, idealized system of particles. So, furthermore, it will be assumed that the body does not undergo any change in size or shape. So, translation of the body results in every line in the body that remains parallel to its origin. Okay, 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 okay. Too many words. So why not we summarize it? I don't need that many words. I don't even have to read that many words. Like I literally have AI which can teach me what's going on, and the mouse is sensitive. Let's just scroll down a bit. I'll try my best to finish 2.2 today, and then whatever I have learned from 2.1 and 2.2, and then I'm going to combine them and put that as to chapter 3. So this, what I'm doing right now is specifically for chapter 3. So what I'm doing is I'm going to finish chapter 3, I'm going to finish chapter 4, and I'm going to finish chapter 2 all at once, because chapter 5, you're going to use chapter 5. I'll try to go through C++ because this is embedded C, which is different from C++. But I'm going to use C++ for chapter 5. I may learn either Rust or CUDA for chapter 6, because CUDA is, you need a GPU for it so that it's able to run this. But first of all, I need to focus on, you know, being able to simulate the program, the maths, and all that stuff. Just zoom in a little bit. I'm happy. I feel good. Everything will be good. Everything will come into fruition. Just that we need to be a little patient. Patience, patience, patience. All right, let's do these four. Let's do these four one by one, step by step. What is going on? What do I have to know in terms of the code? What is going on? What do I have to know in correlation to the code, the program, the maths, everything? Slowly, slowly, slowly. Calm down. So they are asking, how do we mathematically predict where the missile goes? So before we can build the guidance, the MPC, the Kalman filters, the adaptive models, we need a physics model. The book is building the physics model. So what does rigid body mean? The book says rigid body, which means the missile does not bend, the missile does not stretch, the missile does not change its shape. For mathematics, missile means one solid object, right? Because I mean, in engineering perspective, you're gonna say missile is a launcher that had like targets maybe the um, enemy target or enemy radar or the enemy opposition, whatever you want to name it. For physics, pretty similar, but for maths, you're gonna consider that a missile is an object. So it's the same as considering a dot. Because at the end of the day, you don't have definitions for missiles in correlation to maths, but because maths is full of equations, not what is a missile. That is engineering or that is physics perspective. But in correlation to math, missile is a dot. So what does this mean? So instead of saying nose or wing or tail or fin or engine, because maths don't understand that. Because if you think about it, maths only has numbers, maths only has coordinates, maths only has direction. But you can't, it's like saying going up to a mathematician and then you ask how to build, like asking about hardware. You're not going to ask a mathematician about hardware because a mathematician only does simulations or a mathematician only does the equations, but he doesn't do the hardware manufacturing, right? So you're not going to go up to a maths program and say like, okay, which one's the nose, which one's the wing? They don't understand that. They will only understand position, velocity, orientation, or maybe uh, uh, very accurate cases. You may say position, velocity, orientation, but at the same time, you have force or you have acceleration or direction, where it's moving and stuff. Orientation is in angles, right? Position is value, velocity is value, orientation is value. So this is why these three are considered, because these three variables are represented in values. So why do we care? Because that in my abstract it uses state estimation, so we need to focus on state estimation. But before focusing on state estimation, we have to do rigid body equations and stuff. This state body estimation is later on. So it needs a physics model. So the constant mass, the book says dm by dt is equal to zero. So meaning the mass does not change. And for a real missile, the fuel burns, the mass changes. But for the first mathematical model, the mass will stay constant. This simplifies everything. So obviously, the mass will change continuously. But I'm gonna not focus on mass being constant, because you must understand I'm building this as I'm learning. I'm gonna always I'm not going to go for assumption. I'm gonna go for the realistic value, and I'm supposed to get paid today. So yeah, still waiting probably. I'll check at 4 o'clock. So mass does not change. So in codes, I'm not going to say float mass or whatever. I'm not going to say that. Okay, no. Before you move on, understand that what I'm doing is actually building the AI model. So uh, let's not have any assumptions or constant values. Let's keep everything continuous values. So for actual goal, the mass will constantly change, the velocity will constantly change, the position will constantly change, everything constantly changes. So okay, yeah, okay, fine. For the derivation, we simplify the equations as that. All right. So for example, instead of float mass 100, float value, so 100.0, we're gonna say type df. So type df. I have one question. I think you have to say it here, right? Underneath. Okay, we can say that. So type def structure. How do you write? Yeah, structure. Nope. Mass. Mass rocket. Fuel mass burn. Fuel mass burn. Fuel mass burn. Burn. Okay. And then we're gonna have burn rate. Now fuel mass, because you just want. Okay, we're gonna call it rocket parameters. Why if Okay, wait. Oh, we can move it all the way at the top. Okay, no worries. The propulsion mass will be propulsion mass minus the propulsion burn rate. No, no, I'm not going to consider any values. I'm going to write the equation. The propulsion mass, not propulsion, mine is rocket parameters. Rocket parameters. No, I'm not going to use any constant values. Rocket parameters dot mass rocket will be minus equals burn rate. No, fuel mass times burn rate. Oh, it should be okay. Rocket parameters dot fuel mass. My bad. Why is this wrong? They keep. Or you removed everything or what? I think, yeah, you removed everything. Okay. Let me get out of this. No, 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 no. I'll focus on my thing. So I'm going to write type def struct. When I have float mass, float fuel mass, and float fuel burn rate. I'm gonna get an earring today. I'll see if I can get an earring today. Shit, man. I don't know if I'm getting paid today or not. I should get paid today. Worried, man. Anyways. All right. Uh, float fuel mass and float fuel burn rate, and then we're gonna have propulsion. So we're gonna write propulsion. Nope. Propulsion dot mass will be minus equals propulsion fuel burn rate. No, is equal to them. Man, this auto. I don't know how do you stop that. How to stop this auto completion? How to stop auto completion in Visual Studio Code? Open settings, so control comma, quick suggestions. No, I don't want this. Oh, you can't. Um, yeah, I don't have this. Yeah, I don't have this option, right? I think the fastest one will be or Control Shift P, then go to Open User Settings. Where is Open User Settings? Open User Settings, and where's the suggestion thing? So I'm going to copy this. Okay, fine. So like that. Is it like that? Oh, not now, not now. So we're going to copy this. Select all. Where's select all? Okay, there is no select all. Control S. Okay, is it still the same thing? I think it worked. We're gonna write propulsion mass is equal to propulsion mass minus the propulsion fuel mass. What? What? It's propulsion. What? Okay, what's the... What are you doing? Okay, wait. I'm so confused. You're removing that, right? Okay, what is going on? So I'm trying to... Okay, so wait, just wait. So in this code, I know what's going on. I know how to perform and stuff like that. So I know the code. I know the code. However, when I try to find out what the error is, it automatically removes the the mass, fuel mass, and burn rate code. Okay, then what mistakes am I doing? Okay, so I can show you one more time. So we're gonna write type def. So type def structure, struct, have float mass, float fuel mass, float fuel burn rate, right? That's correct. Oh, I forgot to name it. We're gonna say propulsion. I'll do what he's doing. Propulsion, right? No, 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 no. Okay, here, this is what I did. This is what I did so far. So far, this is what I did. So far, this is what I did. No, I'm not going to use constant values. That's the thing. I don't want to use constant values. Oh, do you have to use constant values? I don't want to use constant values though. I don't want to use constant values. So, so you for now you want me to use constants. So for now you want me to use constants, and then as I go along, you want me to. Okay, so I think for now, okay, I'm going to follow that then. I think they want me to input the values for now. For now, they want me to input the values. And I'll do just that. Then on the later times, they'll say, like, okay, you have to do this model, you have to do that model. Okay, so this is what we have. The propulsion. Let me just with mass as fuel mass. I'm just going to write properly. Print mass. What are you doing? Oh, mass dot to mass is equal to dot f dot percentage. Sorry, percentage dot to f. Okay, did I make a mistake? No, I don't see any mistake. Why am I getting an error here then? Percentage to f, percentage to f. And even if I do, and it doesn't matter. When I write propulsion, I know what's going on. Just wait. Propulsion dot mass. What's the mistake? Yeah, just give me 2 seconds. I may have to end.